Hey, I'm checking to make sure we have sound and video. Hey, I'm checking to make sure we have. Looks like things are going pretty well so far. Keep this one up. I'll keep chat kind of over to the side. And yeah, we'll close this for now. So afternoon. Thanks for joining live stream or for watching this at another time. I appreciate it. Things come up. It's part of being a dad, but my son isn't feeling well, so I had to stay home. My wife is off at work, and that's where we're at. And last week, before the 3-day break, before our one break of the semester, we were going to look at homework 0, but we didn't get to it, so that's okay. We'll work on this today. So if you look at homework 0 on our main web page, and here I'll pull up Husky CT, log in, come to courses, 2120, just so you can see same thing. So here we're getting started. Quiz 0 we took a look at last week, and now we're at homework 0. Main goal is get a PDF of your work in, this is called a Jupyter notebook. And I just wanted to get used to this because when we get into module 2, we'll be looking at more Jupyter notebooks. So anyway, if you're in the homework, you can click on this Jupyter Hub, or if you come into the syllabus, one of the first links that you see is our Dynamics tool. So we can launch this tool. And the first time you try this, let's close out these. So it's redirecting. And while it's doing that, I'll show you. So first time it'll tell you you must log in. And there you can use a Google sign-in, it works pretty well, or you can create an account. But these institutional credits, they don't work. So either create an account or sign in with Google, and it'll just ask you a few names like username, password, contact info, and all that. Okay, so now I'm in my Dynamics NanoHub tool, and I can come down to this getting started with Python module 0. That's our homework 0. And just resizing here. So there is, let's see how this one works. Screen key T1. When you hold shift and hit enter, it'll run things, and I can use the arrow keys to move around. So I'll turn off this screen key in a second because it pops up in my face and it's a little hard to see things, but I wanted to show how things work. Then if I hit enter, it brings me into the tool so that now I can actually edit things, change 2 plus 3 to 2 plus 5. Output still says 4, so I'll hold shift, hit enter, and now I have 5. Another option is if I want to run something but get a new cell. So each one of these things is called a cell. So if I want to get a new one, I can hold Alt, hit enter. Now I have a brand new thing to say 1 plus 2 plus 2 plus 3, and there, now I have 6. So let me turn that off. Yeah, just because. Oh my god. Why is it doing this? Oh my god. Now my screen key is broken. Oh, there we go. Whew. Okay. Little bug in the screen key displayer. Okay, so there's Python kind of using it as a calculator. And let's skip down. There's a few kind of exercises in here to practice using Python. I'm going to skip over these for now, but take a look at them, especially if you haven't used Python in a while, or you want some practice with Jupyter. But let's skip over these, because what we're going to do is come down to, so here's some logical stuff, the problems. This is the main requirement for the homework, for homework 0. So I have a box, and I want to know what's the volume, the density, and then I want to check the dimensions of it. So I'll delete old stuff. So what is the volume of the box? Well, I know how to do that. I'll say, we'll call it vol equals 12.5 times 11 times 14. And I get nothing. Nothing comes up. It's like, well, I calculated the volume. What is it? And here we have two options. We can either add one more line so that when we run it, it shows us what that output is. And that's great. It shows us what this operation actually does. Or the other option that I like a little better is that I print out that volume, and then I can choose what kind of units. Like I can add extra stuff to say, like, all right, this is the volume in inches. And really the way that I like to do it is say volume equals so just like this. And if I'm using print statements, I can do as many calculations as I want in one cell and print out the outputs from each one. So like here in the next line where I want to figure out density is the how many pounds per, or let's see, yeah, so we want 31 pounds divided by volume, and I'll say print and then there's a whole bunch of extra significant figures here, which is fine. Like it's showing the result, right? But if I want to tell people this is the density, then they probably don't need to know about all of this stuff. Probably 0.016 is more than enough, especially since I only know that it's 31 pounds. It's not like it's 31.98763 pounds or something. So I can change that. I can say colon 1.3f to say that it's a floating point. I want to print out a floating point number. I want at least one digit on the left side, and then I want or at least one space, and then I want 3 spaces on the right hand side, so it'll round it down to that 0.016. So now it's time to ship the box. I need to make sure that these dimensions match these dimensions. So 15, 13, 12, and here 12 and a half, 11, 14. It seems like it's small enough, right? And there's more than one way to do this. Here is one way. Oh. And earlier in this document, we talked, there's an introduction to NumPy arrays because we're going to use those a lot in trying to do our calculations. So here's like an array. If you've used MATLAB before, everything in MATLAB is an array. It's always a two-dimensional array or a matrix for everything. With NumPy, you can choose what the dimensions are, but here so let's say my dimensions are 12.5, 11, and 14. And then we'll call it like the check dims is 13, 12, 15, 13, 12. If I could spell. And what I'm doing here is I'm taking my dimensions, checking them against the check dimensions. And what I find is that these first two are true, but this last one is false, that 14 is not less than 12. But that's not, these dimensions are not necessarily in the right order. Like if I call this my, if I call that my height, like this is called 11 the height, it is less than 12. So one way that I can kind of make sure that this is true is I could say sort. Maybe like that. np dot sort. Sometimes it's sorting it from smallest to largest. So we could do that. We could just sort both of them, right? Or we could sort in opposite order or something, or sort the negative of them or something. But so now I know that that's true, true, and true, and this thing it's good to ship. And yeah, and I recommend using like an if and an and statement. And we could do that, or we could do yeah, what what do I want to call this? I was just thinking, so if I sum this, if I take that whole thing, every true value is a 1 and every false value is a 0. So I could say like, all right, if I add up all the 1s and 0s, is it equal to 3? And that works. Or we could say like case 1, case 2, case 3 is this. So it's going to take these 3 statements, if case 1 and case 2 and case 3, print package is ready to ship. Oh, and the weight has to be less than, and and that one is kind of trivial, that 31 is less than 35, but let's print out. Just so we can see all that. And I'm just checking to see like what is there versus what was I working on my own. Okay, so now we're going to do some physics using kinematic equations. Remember, kinematic equations is describing like geometry of motion. So I have motion described as like a one-dimensional motion, like it's slide. So x is how far it has slid. And let's go Zernal. So I have some x of t. There's some kind of, oh wait, it's a chair, right? And it is moving along the floor kind of this way. So at any point, let's make a copy of it. So at any point in time, I know how far it's gone. And if I look at the free body diagram, for the most part, I just have mu times n, some kind of gravity, some kind of normal force that way. So it's sliding across this floor. I know mu, I know where it started, I know how fast it was initially going, and I can figure that out. So let's set up these variables. I'll say mu is 0.1, x0 is 0, v0 is 3, g is 9.81. And here, this one is a Python thing. So if I want to add units, I can say this is meters per second, and this is meters per second per second. It's not saving those values. These little hashtags are creating comments. So it gets ignored by Python, but it lets me keep track of my own work. Okay, so now I have these initial values set up. Let's look at x and v. And I'll just try it to start. Is x0 plus v0 times t minus mu times g times t squared. And this is also, this one's a little weird. Square is a star star, not, don't use this one. That will give you, well, that's a different error, but okay. t is not defined. What? But I just want to say x is a function of t. Like, well, I could solve for x as I could create a function called x, which is a function of t, or I could just define t, because it's an independent variable. So I can define time for any time period at any point in time that I want. So let's use that linspace function. And I'm grabbing that from, if I scroll back up here, there is, let's array. Yeah, linspace like that. So I'll say 0 to 5, and the more points I'll start off with like 51 points. All right, so now there's no errors, but I also don't have a plot. So now I want to plot what happened. Plot t and x. I start at position 0 at time 0. I move to maybe 2.1 meters away from where I started, and then I end up after 5 seconds negative 10 meters. So coming back to this idea, that means that the chair started sliding this way, got about 6 feet away, and now it started sliding backwards, negative 10 meters. Something's weird. That can't be right, because friction, there's something about friction where it's constant, but you have to be moving for friction to be like sliding. Otherwise, there's a different friction called a static friction, which makes sure that you're not moving. So I want to change this graph so that when I hit this top, I stop moving. And that's what we're doing here. It's like, all right, so that means that I need to figure out this v of t term. So v is v0 minus mu times g times t. Oh yeah, this should be divided by 2. Do I have that up here? Yeah, 1/2. But it still starts sliding backwards, not as much as before, but I forgot to add that divide by 2. So let's, instead of plotting t and x, let's plot t and v. And we can see that we start at 3 meters per second, and every second we're losing 1 meter per second until we hit, well, about like 1 point, maybe slightly less than 1 meter per second, but it looks about linear. It looks about like a 1-to-1 line, 0 to 1, 3 to 2, then 2 to 1, 1 to 0, 0 to negative 1. So let's just look at v more than or equal to 0. And again, this is that Boolean operation where we were doing something similar here, where I was looking at like, is this less than or equal to? I'm going to do the same thing here. Is it more than or equal to 0? And I'm using this Boolean indexing. Oh yeah. So now I'm only grabbing the values when I have speed that is 0 or more. That's a good start. So now what I could do, let's take this whole thing and look at x. So now I have from 0 to 3 seconds, I was moving forward, and then at 3 seconds, I stopped moving. If I want to look at what happens as I continue, really I should stop. Whatever this value was, that should be the same value for the rest of time, because the chair should stop moving at that. So I could make a plot doing that. This is this is kind of what I was asking for to begin with, I guess. So I was asking you to kind of troubleshoot this. I'm like, okay, make a plot. Plot looks weird. Let me just grab the times when velocity is more than 0, and now update the plot. Like, okay, this is the right one. So let's add another one. So now I'm going to add a new line of code. Let's do this. And grab this. So if v is less than 0, velocity should be 0. If v is less than 0 for this x value, then I want it to be this maximum. I want it to just be that same constant value. So I'll say np.max of x. And I'll see what happens if they're both on the same plot. Oh, you know what I should have done? I should have done this one first, because now there is no velocity less than 0. That's why it's still moving backwards. Or because I set it equal to 0, I can say that it's equal. So from 0 to 3 seconds, I'm moving forward, then I come to a stop, and now I stand still. And that's what I see here, is that velocity goes down, then stops, and then here, same thing. Cool. And now, so I have these plots. They're unlabeled. It's a good first step, but if you are and do we have labels up here? Yeah, so here I show you how to make labels, like X label, Y label. So I could grab these. And for the most part, I'm just using like time. And I already replaced everything. So let's run from top to bottom. And this is now my Y label. And my X label is chair position and time. And then I have chair speed and time. And now this should be that same chair position and time down here. Like this. Now I have two different, like my y-axis has two different values on it. This is both 3 meters per second and 3 meters, which is a little confusing. So one way to do that is say that it's position slash speed of like it can be both. It's not great, but then we definitely need to label these things. So let's take this, we'll throw it into Copilot. I don't have like a specific AI that I prefer. I mean, I prefer open access AI tools, but let's give AI, like I want to label these two lines in my graph. So let's ask AI how to help us with that. I am trying to create a legend for a plot with two values on the y-axis, position and speed. You are a Python programmer. Help me modify this code to make a legend and make it clear that the y-axis has two measurements. So it's thinking about it, building some kind of Python code for us, analyzing, slowly coming in. What's it doing? All right. Oh my God, it's like creating a whole. There we go. This is what I was looking for, was just the label. That's all I needed. But it's like making up its own sine and cosine, which, I mean, cosine is the speed of a sine wave, but I don't know why my chair would be a sine wave. But this is what I was looking for, is that I want to label these two. So really what I need is this. Let's grab the comma. Why is it moving so slow? Let's just come back. Oh my God, can't type. Then the last thing is that we need that plt.legend here. And now I have chair position and chair speed chain. I can't spell. Just like that. And this is, in this case, I used AI to kind of figure out like, how do I make a label and how do I get that legend onto my plot. But I didn't copy the code. I didn't copy this code directly in. If I want to take this code and copy it directly in, that's okay. It's not okay for this one because this is not the same problem that we're solving. This would be like a chair connected to a spring on a frictionless floor, but we have a chair sliding on a friction floor. But that's a whole separate issue. And it's not even the right time span. So, but if I did want to take this code, just copy it, paste it directly into my notebook. I'm not testing you on your ability to create Python code, but you should be able to kind of see like what are the physics involved here, like why is it doing this, or these kind of things. So if you're doing that, then there should be some kind of indication of like code generated by Copilot with prompt everything is. And the control question mark, comments and uncomments. But this is a great way to say like, hey, I'm using ChatGPT. This was how I'm prompting it. And I don't love how this is all kind of getting formatted anyway. So really I would take this, just make it a, change this cell to a markdown cell. Or wait, let's change it back to a code cell. Undo the comments, and now change this cell back to a markdown cell. And here, 1, 2, 3. 1, 2, 3. And that way I know like there's some ChatGPT, like how, or whatever, ChatGPT, Copilot, they're all kind of different versions of similar tools. And yeah, very different kind of process, data, access, like all those things. But this helps me and the TAs know, like, should we be like really focused on helping you revise this code, or should we be helping you like trying to deal with prompts and edit and like getting from the prompt to the right code? Because it's very different. Like if you write all of this from scratch, then that's great, and you practice a lot of stuff. You probably struggled in a different way versus like prompting things. You're also probably kind of learning and testing things, but it's more of a black box of like, here, do something for me. Like what we used to call it when I was using Python to write C code was it's like a meta programming language. You're using one language to program in another language, and that's kind of like Copilot. Like you're talking to a computer, giving it commands, trying to get that to create commands for you that you can send to a computer. It's weird, but also kind of cool because we can do like cool stuff like this. But anyway, that's what I had for today. I hope this helps. Oh, yeah, actually, that's not all I had for today. Last thing, and I guess this is the important thing, and I'll put up the announcement part to this too. So we're done. Let's say we're done with homework 1. We're happy. We're happy with the way that it looks. I'm going to create a print preview, and that'll pull up like a static website of all of my work. So if I scroll down to the bottom, here's all this stuff that I just did, including even my little markdown cell that says like, hey, I used Copilot with this prompt. I have all my graphs. I have the code that I worked on. I have this problem 1. So now that I have a print preview, I'm going to say Control P, save as a PDF. Let's save, and let's call it like my Coupa interactions. In my downloads folder, it's fine. And let's switch to student preview. So I'll go through the same process that you go through. Come down to module 0, homework 0, submit homework 0. I'll view the instructions, nothing there, that's okay, because all I need is to add my Cooper 01 interactions, and that's fine. And it takes a second, but PDFs usually show up pretty well within Husky CT. Ideally, I would have other ways that you could send in like Jupyter notebooks, like the IPYNB files, or other versions of that. But now I have like all this stuff kind of submitted in here. Yeah, and it's got everything else. And submit that. Submit. I don't need the submission receipts. It gives you one. You don't have to save them. I trust you. If you think you submitted it today at 1 o'clock or midnight or something, but for some reason something broke, you don't have to show me like the confirmation number. Things happen. It's a wild world out there. And that's it. Now I've got it submitted. And if I made a mistake, you can always submit another one. Like, oh no, I actually, go back here. Like, oh no, I forgot to write in like I forgot to add this for loop in there. So let me make a print preview, print it, save, overwrite my old one, and then open this one. Save, and it'll take a second again, or I'll just submit it. Just hope for the best. Close. So now I have 2 submitted files. This is my second attempt. It's still converting. But now I have that second version with 10 Hello Professor Coopers down at the bottom. But that's what I had for today. Not too, I know it's a lot less interactive in a live stream like this than it is to be in class. Friday we'll be back in the classroom working on some more dynamic stuff. But so if there are problems or things that come up or you need to ask questions, you can always submit a note in here. Like, I'm stuck on this HW, I need help from in Friday's lecture. And you could have that as your submission. That's the main things that I need to know is like, are you stuck? Like, do you need help? And then how are you getting help? And then the next part is like, I'll submit on Friday afternoon. So I know there's a new that you set yourself a new deadline, and you're not just hoping that you'll get it, that you have some kind of plan for getting help. So those are the 2 things that I need if you're still stuck here. Okay, cool. That's me talking for 45 minutes, just here on my own, having fun, doing Python, a little bit of physics, some engineering. And I'm looking forward to getting back into classroom, and then we'll be able to do some more work together. Thank you. All All right, have a great afternoon. Stay safe, be healthy, and I'll see you Friday.